Hi guys, welcome back to physics. We are going to do a lab today on Newton's second law of motion. It's going to be pretty cool. We're going to use the carts and the tracks, and hopefully you guys will think it's at least somewhat interesting and does a good job of making sure that we understand how Newton's second law works. Remember, Newton's second law is the one that says F equals ma. That is, the net force in any situation is equal to the mass involved multiplied by the acceleration of the object, of the body, as we say in physics. So you've all got a paper that has this exact same procedure on it. I'm just going to give you a rough idea of what it means to make sure it makes sense. We're going to set up a track using, let's see here, it's called dynamics track. It's just the tracks you see on your desks, and we're going to run the cart back and forth on them with a mass, that's the weights that you see, attached to either side of the track. Or either side of the car, sorry. A small mass, which in this is going to be M1. So whenever you see M1, it's talking about the small mass, is going to hang over a pulley, and it's going to pull the cart, and whenever you see M2, it's going to be the mass of the cart for this lab, along the track. Which looks kind of like this. Excuse me. So right now, you've got your track set up on your desks, it's already got the pulley on it, and it's got what we call a photo gate, which uses a laser, and whenever the pulley spins around and around and around, the spokes on the pulley block the laser, and the LabQuest, which you're going to have plugged in here, is going to use the rate at which these spokes block and unblock that laser to calculate speeds for us. So here's your cart. It's not on there yet. Hopefully it should be upside down so that it doesn't fall down. And here is what we're going to do. We're going to run this rope that's currently on the cart over the pulley and down, and onto that rope we're going to attach a hanging mass. Now here it looks like a block. It actually looks more like this. Ta-da! So you've got these in your groups. This is the hook that's going to hang all of the masses from it. So this end is going to be tied around the string. You'll have to make a loop in the string, a little loop, and then we hook this hook through it, just like a clothes hanger. And this disc on the bottom allows us to hang weights on it. Everyone should have a circular weight, which we can hang on this. We'll see a picture of it in just a second. And that's what's going to hang off of here. But you'll see what we're going to do with it in just a second. Okay, so a rough outline. We're going to use gravity to pull down that small mass. That's the weights we talked about in the last one that you'll see a picture of in just a minute. This is going to cause the system to accelerate. Remember, forces don't cause motion. Forces cause acceleration. But first we're going to predict the acceleration each time using this equation. A for acceleration is equal to m1 times g, gravity, divided by m1 plus m2. Remember, we said m1 is the mass of the little weight, the one that's going to be hanging off the end of the rope, and m2 is the mass of the cart, or the cart with stuff on it, as you'll see later on in the lab. So you've got the mass of the little weight times gravity, and that's a number, and then you divide that number by the sum of the little weight and the big weight put together, and that's going to be our prediction for what our acceleration should be. Then we're going to actually measure the acceleration and see if it matches our prediction or not. We're going to use LabQuests, our good friends the LabQuests. In case you've forgotten about the LabQuests, they look like this. Ta-da! And they are over at the edge of the room. When you're done with them, please don't forget to turn them off and plug them back in. If you don't, they're going to run down by the end of the day, and the other groups will all be very, very sad, and they'll probably hunt you down. I won't stop them because you're a jerk if you don't plug it back in. So please plug it back in and turn it off so that other groups can use it. We're going to use this, and we're going to plug in the photo gate. That's the U-shaped thing on the end of the track. It looks kind of like this. It's got the wheel on the inside of it right there, and there's a cable that comes out of it. It's on the side usually. Sometimes it's over here or over here, but this cable right here is what plugs into the LabQuest over here. So we're going to run it one time after the first trial. So first we're going to run it like I'm going to explain in a second. Then you're going to gather your data. Then you're going to do it again with extra mass, a couple different numbers of weights applied to the cart or to the pulley, and we're going to measure each time, and we're going to see how this affects the acceleration. So the setup has largely already been done for you. Luca Summers, my TA, did it for you. If you're in 6th period, Luca's in the back. You can wave to her and say thank you. I'm sure she'll wave to you if she hasn't already left for the library. It's mostly set up already. The photo gate, that U-shaped thing, should be all set up and ready to go. There's blue tape on it. The tape is to keep it level with the track and with the pulley. If it looks like it's not level, ask your instructor to come over or take a look at it. Remember, the whole idea is that we've got our lovely, you're going to see my terrible art here for a second. We've got our lovely photo gate here. And it sends a laser beam from there to there. And then there's a wheel, the pulley, that should be like this. Here's our pulley with the spokes. And the idea, that just got a whole lot uglier. Sorry about that. The idea is when this spins, these spokes are going to block this laser beam right here. You can't see the laser, sorry. But if this pulley's not lined up with this, use the tape to tape your photo gate in place so that it's all level with the track. So first you've got to balance the track. If you've got a track that's wonky like this, and here's your table, obviously gravity is going to cause your cart to roll right down that thing, and it won't be because of your weight. So you want your track to be level. You can do this by wedging whiteboards or a book or just sometimes just a few thick sheets of paper under the different sides of it. Most of them are pretty level to begin with, but make sure it's level. What you can do is do your best to make sure that the track itself is level by setting the cart on it and then seeing if the cart rolls to one side or the other. It's okay if it rolls a tiny bit, but it should mostly stay still. Right now, this step is pretty much done for you. We've got the hanger, that's the thing we saw earlier, has a mass of 50 grams all by itself when there's not currently any sort of weight hanging from it. We got a string, it's already attached to the cart, you run it over the pulley, so here's your cart, here's the pulley on the end of the track, you run the string over the pulley, there's a little track for it, and you're going to hang your hanger off the end of it with no weights on it yet. This thing right here has a mass of 50 grams, that's our M1. The cart all by itself with nothing else there has a mass of 500 grams, that's our M2. Write these down, by the way, if you haven't, because you need to know these numbers. They are in the procedure, the blue paper, the class set that you've got, if you're unsure. So, next, you're going to plug in the photo gate. Remember, we've got our cable that comes out of this that plugs into our lovely LabQuest. It's got to go into the Dig 1 part of it or it won't fit. Now, at this point, dear substitute, thank you so much. You can go ahead and pause this if the kids are unsure because they have to make sure they set up their LabQuest properly. So at this point, if you haven't done it yet, go ahead and pause this screen and go get the LabQuests. Make sure every group has your LabQuest and they're turned on. Once they're turned on, once everything is turned on and it's plugged in, if it's not plugged in, you're not going to get the right menu. So everyone has their photo gate plugged into their LabQuest. You're going to tap the sensor menu. It's one of the menus across the top. I believe it's the one that looks like this. It's got like a little half moon there and like a dial, like it's measuring something. You want to tap that menu. Either that or it'll be the word sensor. And then select Sensor Setup. There's different types of photo gates, so we got to make sure that it's set up properly. So you'll tap Sensor Setup. Then there's going to be a menu called Dig 1. The Dig 1 menu is talking about this thing where you plugged it in. So you'll press the Dig 1 menu and you'll select Photo Gate. So Sensor Setup, Dig 1, Photo Gate, and then OK. Now, once you've got your photo gate done, and feel free to pause this again if we need to make sure everybody's in the same place. If you've got it, if your group has got it, go ahead and check with the group next to you or the group behind you. Make sure you're helping them out because this will be more fun for everybody if we all know what's going on. So if your group has got it, just be a pal, circulate a little bit, and make sure everybody's got the right stuff on there. Then, on the right side of the screen, there's something called the Mode box. and we want to set the mode to photo gate timing, and the photo gate mode we want to set to motion. Mode is set to photo gate timing, and the photo gate mode is set to motion, right there. Finally, you want to select the 10-spoke pulley. That's the machinery we're working with, and tap OK. If this doesn't make any sense, if you just cannot get it to work after trying for a little while, remember, we've got the other physics teachers upstairs. They do have their classes, so we don't want to just burst upstairs and say, Mr. Calvin demands that you help us now. But we could send a student politely up to see if any of them are in a place where maybe the sub could switch places with them for a few minutes to set up the lab quests. Okay, so here's where we're going to do the actual lab. One of you is going to move the cart backwards until the mass hanger, remember the mass hanger is this thing, the thing that holds the mass, almost touches the pulley. So here's your cart, here's the car, here's the pulley. You want to pull the car back so the mass hanger is right there. It's about as high as it can go. And then the other person, well, person one's still holding the car to keep it from rolling, because the mass hanger is going to pull it downwards. The other person clicks Start Data Collection. Remember, that's the little play button. Oh, it's the same button we've used to collect data on all of our other labs. You'll click that, and then it's not going to click. It's not like our motion detector, so it's not going to make any noise. Once the red stop button appears in the bottom left-hand corner, that means you're collecting data. That button means you can stop it if you want to. So press Start, and then person one is going to let go of this cart and let it roll towards the end. Don't let it roll off the end. It's not going to explode into flames or anything like that if it lands. But they do take a tumble every now and then, and it beats them up. So don't let them fall and explode in not flames. Just catch it before the end, please, if you can. If not, catch it underneath. It's okay if it falls. It's not the end of the world, but be careful with it. Once the cart goes all the way to the end, so it's down by the pulley, then whoever's collecting the data will press Stop. Or just the play button again. I like to use the stop button to make sure you don't collect more data. So, to review, person one holds this. Person two presses the Start Data Collection or the play button, and a red stop button will appear saying that you're collecting data. Person one releases the car, it goes forward, and right about here, they're going to catch it before a horrible catastrophe happens, and person two will press Stop. So we've got our data. Go ahead and pause right now for everyone to do that. Make sure it makes sense for everybody. If you're choosing to watch this before you start the lab, keep in mind you can always come back to this video to tell you what to do. So we've all run the cart, we've all got the data. Once everyone's got that first set of data, or everyone understands how to get the first set of data, go ahead and then move on to the last of the instructions. You're almost done. Your lab quest is going to give you a velocity versus time graph. Those are the same graphs that we've been using in all of our other labs. We've got velocity on the y-axis and time on the x-axis. And you're going to do, just like we've done before, tap and drag and highlight the straight portion. So if your graph looks like this, and it goes, let's see here, straight and then goes down, or weird things over here, you want to highlight just the straight portion. This portion right here with your finger, that's what we want the lab quest to do its calculations with. Once you've got that portion highlighted right there, type the Analyze menu at the top, and just like before, Analyze, then Curve Fit, choose your velocity graph. We don't want to do position, and fit equation to linear, just like before. Analyze, Curve Fit, choose velocity, and then make it linear, and record the slope, the m in the mx plus b equation. If anyone around you has forgotten how to do this, again, if you could circulate once your group is good, make sure that they get how to do it. I would really greatly appreciate it. This is going to be acceleration. The slope of position versus time is acceleration. So remember earlier I said we're going to compare the acceleration we find in lab to the one we calculated. This value, this slope, is the one that we compare to that capital A that we found at the beginning. Oh, sorry, I was trying to type something here. Let me fix that. That's more like it. That A, where it was M1G over M1 plus M2, that A right there is what we're going to compare with this A, this slope that you just found. Don't forget to write this stuff down. You got to have it in your lab. There's a table ready for you. Then on that table you can compare your theoretical acceleration, that's the one you found in the beginning, with your measured acceleration, that's the one you just found, to find percent error. And the equation is right there in the table for you. All right, you basically get it now. You're going to do this 3 times. The first time you're going to have just the cart on the track. Here's the pulley, here's the string. Okay, with just the empty hanger on it. Trial 2, you're going to do the exact same thing, only instead of the empty hanger, this thing right here, you're going to add a weight to the hanger. It's this weight right here. Everybody's got it. It weighs 100 grams. So you're going to add it onto here. So this M1 won't be 50 anymore, because 50 was just the hanger. It'll be 150. It'll be the hanger plus the 50 gram weight right here. And you'll do all the same stuff and record your data. For trial 3, you're going to do the same thing. So we still have that mass hanger, and we still have the weight on it. You've still got this guy on it. And we're going to add 500 grams to the top. So one of these, each of these is 500 grams. So for trial 1, we had just the cart. Trial 2, we had just the cart. Trial 3, we have the cart plus one of these. So 500 grams here, 500 grams here, gives us 1,000 total grams for our M2 value. And we'll do the same thing, gather all of our data. We still have this over here, this guy on the hanger. And finally, for trial 4, we are going to do the same thing again, only we'll have both of these bars on top and this on the hanger right there. So M1's 150, it's the hanger and this. And M2 right here is 1,500 because we've got the car, a weight, and then another weight. And we'll calculate the acceleration just like before and put it all together just like we were doing. So that's it. If you have any questions, feel free to rewind this or to send someone up to ask one of the other physics teachers. But please try to do it on your own first. I have confidence you guys can totally handle this. This lab is going to be due next time I see you. You should have time to finish this lab in class. If you don't, you can just finish it later. Don't forget you've got your quiz at the end of class today. If this is first or fifth period, your quiz is going to start around 10:05. So you want to be done with the lab by around 9:55 to 10-ish so you can clean up and get ready. If this is second period or sixth period, then your quiz is going to begin around 11:45. So you're going to try to be done right around 11:35 or 11:40 to get it ready. And if you are third period, then your quiz is going to start around 1:30. So you want to be done around 1:20, 1:25 to get it ready. You guys can do this. Have a great time and a great weekend, and I will see you all later.